The second part of y equals mx plus b, which is slope-intercept form. So this is our day 2 lesson. Is going to start on page 6 in your packet. We're going to start off with a couple of real-world examples here and talk about what the different pieces are and what the different things mean, and also discuss how and exactly why this graph matches this word problem here. So it says Jay collects eggs in a basket and weighs the basket. He graphed the relationship between the number of eggs and the total mass in grams. So a couple of things that I want to point out to you that we've looked at over the last couple of days is, first of all, this y-intercept that happens right here. So this would be my y-axis and this would be my x-axis. The y-intercept, if you notice, does not go through 0, 0. So that y-intercept that's a little bit over 100, maybe like 110, 120, is going to be representative of something. So at the start of the scenario, before Jay collects the eggs in the basket, he still has the basket. So the basket is going to have some form of weight. And that weight is actually going to be represented by that y-intercept, because at that point in time, he's collected 0 eggs. So 0 eggs, but he already has the basket. The y-intercept represents the weight of his basket. So the other thing that we can talk about is our slope here. And the slope, if you look, we can actually try and pick a couple points here. We can just kind of look at them. We go from here with 0 eggs up to here with only 1 egg. And so when we go up in those eggs, we could So when we're talking about the slope, if we go from here at this point where we have 0 eggs to this point here at 1 egg, that difference in our y value, that rise, is actually going to represent our slope. So that slope is going to be the amount of weight per egg that he puts into his basket. One other thing to notice is that this graph is going to go in the first quadrant only. And in the first quadrant, we have both positive numbers on our x and y axis. And that should hopefully make sense to you, because the weight of the basket is going to be a positive weight, as well as the number of eggs, potentially starting at 0 if we have no eggs in the basket, but then going in a positive direction. We wouldn't have negative eggs. So with this one, it's not exactly easy for us to read what these points are on here. So because of that, we're not going to be able to yet be able to go ahead and write out our equation for this one. So just as a reminder to you, our slope-intercept form of our equation is y equals mx plus b. This m right here is going to represent your slope. When we look on the graph, that's going to be designated by rise over run, or the change in the y over the change in the x. This b value that we have here on the end, this is going to be our y-intercept. So this is where our graph, the line in our graph, is crossing the y-axis. So we're going to look down that axis. So here's a word problem for us that we're going to try and put an equation to, and then also graph on our plot that we have here. So Sammy's dog walking business is off to a great start. She charges $10 for an initial visit to meet the dog, and then $5 for each 15-minute walk and play session. So 2 things to notice here. That $10 is going to happen for your initial visit. So that's whether or not you book the play session. But if you're booking with her, you're paying $10 to start. In addition to that, you're going to pay $5 for each walk or play session. So the walk and play sessions could change, so that's going to get our X right there. So we're going to kind of flip-flop this around, and we're going to actually turn this into an equation. Y equals 5x plus 10. The 5 is going to be our change value, and that's our cost per visit for Sammy. And that $10 that we have there is our initial visit. So when we look across our x-axis, these are going to be our sessions that she has. And then up on this y-axis, this is going to be her charge that she does in dollars. So noting that she starts at $10 and everything goes up by 5, I'm going to actually count by 5s going up on this axis. So labeling those. And then for the number of sessions, we can actually just have those increase by 1. So Sammy's starting initial value, her y-intercept, is going to be at a 10. So we're going to go ahead and put a dot right there. If we have the $10 initial value, and then we also have 1 play session, that would add on $5, which would take us up here to 15. If we add another play session, we would increase by 5, and it would continue on in that particular trend. So we can actually draw a line starting at that 10, working our way up here. And at the end of my line, I want to go ahead and I want to put an arrow at the end of it because that would continue on up depending on how many play sessions that you get. So that would be a real world example on how you would actually write out your equation and then show it on a graph. Over on page number 7, we're going to be talking about determining slope and y-intercept and then writing the equation of the line. This is a review of yesterday's lesson. So for this first one, starting at our left point, moving up to the right, we're going to actually rise up 7 spots, and then we're going to run to the right 8 spots. So my slope is 7 over 8. And I also want to find my y-intercept. So coming down here, that's down here at a -6. So that's going to be my b value is a -6. With the form of our equation, we're going to have y equals 7/8 x minus the 6 then, representing that line. On the next one, we're going to have to pick 2 points. I am going to pick my y-intercept, which I note is up here at 3. I also need to find my slope. So I'm going to have to pick another point that's right on my line. Looks like that's a good one. So calculating my rise over run, I have 1, 2, 3, 4 for my rise, and a run of 1. So we're going to have 4 over 1. So with that, our equation then, y equals 4x plus 3. So that 4 over 1, remember, reduces to just be 4. So that is what your equations of your lines would look like. So we're going to go backwards with that today, and using the slope and the y-intercept, we're going to actually graph, and we'll also write our equation. So as a note to you, to make this easy, we have m and b are our 2 values. So we're going to start at b, and then we're going to move with the m. So the slope is the m and the y-intercept is b. So I'm going to ask you to go ahead and plot a point where the y-intercept is 1. So on your y-axis, find 1 and plot a dot. Using our slope, remember slope is rise over run, we are going to rise up 3 and then run 5 to the right. So I'm going to go 1, 2, 3, and then 5 to the right. 1, 2, 3, 4, 5, which is going to bring me to right over here. What I will do then is I will go and connect those two with a line. Line's not too perfect there. There we go. And we'll put arrows at either end of our line then to show that it's going to continue in both directions. And the final thing that I want to do is to go ahead and write my equation, which would be y equals 3/5 x plus 1. On this next one, your slope is 7, so that's your m, and I'm going to write that as 7 over 1, and my y-intercept b is -3. So I'm going to start with my b, which is my y-intercept, so go down to a -3, and then I'm going to move with my slope. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, and run 1. And that's going to give my line steepness here. So if I move up, and this is going to be terrible, but you can kind of get the idea of what my line should look like, generally speaking, and put arrows at the ends of it. So then for my equation, y equals 7x minus 3 for this one. So when you're graphing these, start at b and then move with m. On the next example, we're going to identify, oh, it looks like I skipped a bunch again. Oh my goodness. All right. So on the next two that we have, which are actually on page number 8, which it looks like I skipped over here. So on page number 8, up at the top, we have a slope of -5. So that's going to be your m, which will be -5 over 1. And your y-intercept, b, is going to be 4. So when you're taking a look at your graph, this is going to be a very rough sketch. We're going to come up here to 4 on your y-axis. You're going to go down 5 and then to the right 1. So that'll come over here, and that's going to give you a line that's going to look just about like that, and put arrows on both ends. And again, to write your equation, you're going to have y equals -5x plus a 4. For the next example, you have slope is -6/5, and your y-intercept is going to be a -1. Should actually be a b there. So on my y-intercept down here at a -1, my slope, I can move that negative up to the top, which is going to tell me to go down 6. 1, 2, 3, 4, 5, 6. So So all the way down to here, and then 5 to the right. 1, 2, 3, 4, 5. So you would be down here at the point 5, -7 on your graph. And then you would just connect those two together with a line. And extend your line a little bit and put those arrows on your equation for this graph. -6/5 x minus 1 is going to be your graph. In the next two down at the bottom, identify the slope and the y-intercept, and then you're going to graph them. So remember, y equals mx+ b is our form here. So we're going to be picking our slope and picking our y-intercept. So from this one here, my slope is going to be 4, and my y-intercept is going to be this -3. So starting with my b value, I'm going to plot a point at -3. Slope is 4 over 1, so I'm going to go up 1, 2, 3, 4, and to the right 1. And then I'm going to connect those two together with a line, extending down and putting arrows on either end here. In this next example, what is your slope? So your slope here is going to be -6. And what is your y-intercept? Your y-intercept will be up here at 5. So on this graph, that's going to be all the way at the top. For my -6 slope, I'm going to put the negative with the 6. So I'm going to go down 6 spots and then run 1 to the right, which is going to give me this downward moving line that looks like this, extending it slightly past those 2 points and adding arrows to both sides then. So that's how you would go ahead, identify the slope, y-intercept, and graph. Two more examples for you. First one, I'm going to ask you to go ahead and identify your slope. So we get a 7 here. And your y-intercept is going to be a 7 as well. So 7 would go off of our graph. It's going to be up here. Because I can't go any further up, I'm going to actually have to change this so I have a -7 over a -1. So I'm going to go down 7 and actually 1 to the left here as well to actually keep my slope to end up being a positive. That's going to make my line look something along these lines, and that will work for us. In number 4, what is your slope? Your value next to the x is a -2. And what is your y-intercept? Your y-intercept here is going to be a -6. So again, this one's going to go off this graph just slightly. So it's going to be down here. Having that negative slope, I want to actually move up. So I'm going to make the 2 be a positive and then bring the negative down. So I'm going to move up 2 spots, but then left 1. So that's going to give me this line right here, and extend it out and put the arrows on it. And that is it for actually graphing when you are given an equation.